All right, thank you, Gustav. Thank you guys for staying. I mean, I know it's late, we're interfering, but thanks for hanging around. I hope the beer is still cold. So let's start. I will try to get through fast so we can get to the beer again. My name is Michael Pisula. We are interfering. Today is 14th. Just to make sure everyone knows. My topic will be CQRS and event sourcing, surprisingly with Akka. All right, let's just dive in. What is the problem we are trying to solve? I mean, we are software engineers, right? Most of us probably. So everyone loves new technologies, new topics, new stuff to play around with. But at some point, your manager is coming to you and saying, okay, this is fun stuff, but what is this going to solve for me, right? So at some point, you've got to think about what is the problem. Oh, okay. Yeah, so basically what the problem, or maybe not the problem is, but what our usual suspect when we're designing applications is something like this more or less, right? We have a fat user sitting here, and we have a thin client probably somewhere here. Very thin, you can't see it. Then we have some kind of service, which is a gateway to applications. Inside of application is some kind of model, and this model will basically also deal with database stuff, right? So basically everything that goes in here, there will be some validation, some checking, and probably some Hibernate or other magic or magic to transport all our stuff into the database. Basically, whenever the user decides to do something, it will go through the service, into the model, through the model to the database, and back again. This is really independent of what he does. If he tries to I don't know, push some new data into your service or get some data out of the service. I mean, we all can agree, this is awesome, right? It's like unicorns and rainbows all over. Yeah, okay, this is the model we've been using for a long time. This is a model that has worked for a lot of situations. Does it work for all the situations? Obviously not, else I wouldn't probably be standing here. So what are the problems? I mean, one problem you can get is like if our application is like really successful, which should be, this is a spoiler perhaps, but this should be your goal. So your goal should be to make your application awesome and to like make all people want to use it. And if all more people want to use it, you are getting into some problems with your one tiny server not handling the requests anymore. And then you have to scale. And when you have this one database sitting at the back, and you can scale your application. Basically, you can put 5 of these applications somewhere, but one database will stay in the rear. Okay, no problem. We have solutions for that. We can like add a distributed cache in front of a DB, right? I mean, memcached or something like that. That's technology everyone uses, and it's all good and fine. It's going to probably bring some problems, some new problems. Hey, new problems are always fun. Okay, but there are also other solutions. So you can take like a clustered or distributed database, right? I mean, you can have some master-slave setup, something like this. Again, you solve one problem, you get 2 new ones. So that's also very fun. And on top of this whole stuff, at some point you might need to use distributed transactions. And distributed transactions is probably something that will solve one problem, but bring like 10 new ones. So very fun. So for today, let's try a new approach, something that has worked great before. Let's just split some stuff, okay? Yeah, the lights should be out for that slide, okay. But I think we got it. All right, so our topic today, or at least one side topic for today, is common query responsibility segregation. Remember this CQRS? That's the whole name. Just a moment to let it sink in.
Who came up with that name?
Yeah. No idea. Actually,
you mean cars? Did you mean cars?
Yeah. That's. Oh, I should have used that one. All right, next time. So every time you search for common query response, so CQRS in Google, you see, do you mean cars? Very good. I mean, actually, this is so the guy that invented that, basically Greg Young, I think was the first who came up with a name. He cheated a bit because there was something called common query segregation, which came before. So we just added VR and was happy with it. And what he said about this new invention of his is, okay, CQRS is simply just putting two objects of something where it was one before, right? So we just split something and make two parts of it. Yeah, so basically the two parts, so we had this one model before, right? And we split this one model into two smaller models. And basically, it's not very surprising probably that one of these models will be called command model and the other will be called query model, right? So yeah, we're separating commands and queries. What are commands? Basically, a command is any method that will mutate your state. So everything that will change something in your application, right? So a user comes in and adds a new chat message in Heiko's reactive flows. That's a command. On the other hand side, a query is something that will return a value, right? So if a user just sit there and some other guy added a command, a new flow, it will just, a new flow will pop up, and basically this, well, okay, in Heiko's is too reactive, that's not a good example. But if Heiko was polling the backend, basically that would be a query. So in the first version he had, that would be a query. It just returns a value. Does nothing to the state, it just returns the state. Yeah. I mean, some background perhaps on this. No, it's okay. Let's do it later. So again, commands. Let's look a bit deeper into that. I think everyone understood what commands are on a high level, right? So some guidelines on using commands. Basically, a command should always capture user intent. So a command should always be something that the user does. It should not be something abstract like, I don't know, do stuff. And you have like, everything the user does will be this do stuff command and it will be just different variations. But you really should have like stuff like add flow, add message, whatever. So it should be really specific. Every use case you have should be its own command, right? You shouldn't put just everything into a bowl, into one command and make it do all stuff like a magic bean. It's just every use case gets its own command, all right? Now that we've got that covered, queries are a lot simpler. So I've got 4 bullet points for it. One interesting point about queries is queries contain no logic at all right? All the logic you have, you deal with in your commands. When a command comes in, you validate the command, you apply the command to your state, it mutates the state. If a query comes in, okay, sure, you do some authentication, you do some authorization, stuff like that, but basically a command should be just, okay, give me stuff, and the stuff gets returned, nothing more, all right? Keep it simple. The query model can be basically optimized for the query we have, okay? So really don't try to make a query model that can answer all questions. If you have something specific, like you really just want all the flows there are, okay? So like in your example, you would probably just have a query model that contains only the flows, nothing else. Don't mess with stuff. If you have like a product service, right? You have a service which you basically can have all your inventory, you have the prices, you have the stock, basically numbers, all kinds of that stuff. You might have a query model that only returns the descriptions because you want to show them on a page. Only that, okay? No more information about prices and stuff like that. On the other hand side, you might want a query that returns only the prices for the overview pages where the user can just see, okay, how much does this one cost, how much does this one cost. Denormalize it. That way, you don't need to make like, I don't know, complicated queries against the database. It's just simple. Get everything out that's there and display it to the user. And basically, why do we do it? Because queries can be really optimized for faster data access. And that's really a core point of this whole exercise we are doing. I mean, with one model, it had some problems, like I said, but the main problem we can solve with CQRS is we can really speed up the reading side, right? All the queries the user have, we can optimize on that. Because if you think about it, most applications are 90% of the stuff that the user does with it is just queries. Okay, like Amazon. You will have users looking at the store, at the products the whole time. At some point, one user will click on it and buy something, but it's like, I don't know, 10%, 5% of the interaction the user does with a page. So it really makes sense to really optimize the queries, the read access that you get, because that makes it fast, right? I mean, Google, in Google, you have like almost no queries. You don't change the state of Google more or less. You just access the queries. You just access the index and get the queries back. So you really want to optimize to get it as fast as possible because, let's face it, if you're a user and you have a slow application, a slow website you are using, you will not using it for long. You will look for alternatives which are faster. So it's always a good idea to be fast. And yeah, obviously, if you really optimize for fast data access, if you denormalize a query model, you will get to the point that you have different query models for different access paths, basically, right? All right. So now that we successfully splitted our model, it will look a bit like this. We still have our user, we still have the servers, and then behind the servers, something funky goes on. We have a read model and we have a write model. Now, if a user decides, hey, cool, I want me some of this reading stuff, he will just go ahead and issue a command to the service, query to the service. The service will continue it on to the read model. The read model will get it back from the database, will get returned, and the user is happy. Fine. Now the user comes back and says, hey, I saw this product, I want to buy it. He will say, send the command, buy product. This will get routed to the write model. It will be written into the database, and finito. Nothing will be returned. This way we have also optimized the write model. We don't need to deal with sending stuff back and, I don't know, modifying our internal state and stuff like that. It just gets dumped into the database. If a user wants to see something again, he has to go through a read model. For stuff like buying products, it's not a problem. The user wants to buy something. He saw it already. He doesn't need to see it again afterwards, right? So for stuff like that, you can really decouple it. But the interesting point about this is if you can't really just switch from this traditional model to CQRS, your UI will also have to evolve because your normal UIs are just built for this, okay, I write something, I give something back, okay? So you will have to guide the user into this direction. So every time he does something, he will, I don't know, maybe he will get notified by a mail or something like that, but there won't be any feedback on the UI. It makes it just easier to implement like this. Okay. One question that often occurs is, yeah, but now if the user doesn't get the result back, what do we do with stale data? Because obviously now the query model can like return outdated data until this is updated, right? I mean, we write something and then at some point the query model needs to be updated to reflect this changed state. Yes, this is true. I mean, I said we have this, okay, this picture is a bit misleading because we have one database here, right? So it looks like the write model writes something and the read model can access it. But what I said before, come on, faster. We want to denormalize our data also. So basically, we will have, in this picture, we would have different tables for the read model or like something materialized views or I don't know, which basically is not the same thing that is written to. We write something that we can basically just simply update. It's also like we can optimize on this part. We write to something we can just, I don't know, very simply update and read from something else. So basically, we need some method to just update the read model. And while it is being updated, it will all obviously just return outdated information. So basically, yeah, that's right. Make sure it's okay. In some domains, it's a fair approach. Basically, when you think about bank transactions, for example, right? You have your account, you have another account, and you decide, hey, I want to send some money over. Okay, you go to your website, you type everything in you need, and you click on send, and yeah, okay, fairly soon the money will be no longer in your account, right? But if you ever received such a transaction, you know it will take, I don't know, 2 days, 3 days for the money to appear in your account or on the receiver's account. So basically, in a lot of situations, in a lot of business cases, we have this, basically, this decoupling. Some stuff disappears here, and it will appear later, days later at the other end. So basically, but this is one thing you should think about. It's not always really necessary to be like 100% consistent, okay? Normally, in the real world, it's not the case. Yeah, and basically, it's also not as bad as you think, because we already work with stale data anyway. I mean, if this is your laptop and this is a database where the data is always fresh and shiny, basically the data will be anywhere like 100 milliseconds old if it reaches you. A lot can happen in 100 milliseconds, right? In between, another user might have written something and changed the data, so basically the data is already out of sync. So don't really, I mean, consistency is nice, but think about how much consistency you need, right? Okay. I think CQRS, I really don't want to stretch it. I think it's a simple concept. Let's move on to event sourcing. All right, event sourcing. What is event sourcing? I mean, Heiko already told some stuff. Now I'm going to tell some stuff more. Maybe between our two explanations, one of it will stick. Will be the best way. What event sourcing is about is basically you don't store the current state. You store the history, right? And then calculate the state out of the history. So basically, the source of truth in your system will not be the current state. It will be the history, the past events. Okay? So what an event is really it represents the past. Also, the past has already happened, so you can't change it. I mean, if you have a time machine, maybe, but you don't have it in event sourcing. So the event will be immutable. Okay? That's basically event sourcing and events, and maybe I'll just show a short example how that works. I have made this very ugly illustration just to show you how this looks like. Okay, let's go again with this account setting, right? We have some model that represents banking account stuff, whatever, and basically we have a command here, or an event, basically it's a command. And the command says, okay, I want to withdraw 100 euros, okay? So in our usual model, or in this basically state-minded model, we will have a table somewhere, and it will say, okay, account, this has this balance, okay? And afterwards, after this command got processed, we say, okay, this account has now this much balance. This is cool. I mean, it's okay. We would do it in different applications. It's not really cool for banking applications because your users might want to have like an overview what happened. So, you know, this Kontoauszug. What's Kontoauszug in English? I don't know. But basically,
Account statement.
Oh, account statement. Thank you, that one. I understood it anyways. All right. So, yeah, you want to have something like this, right? And basically, that's exactly what event sourcing is. So, with event sourcing, it would look like this. You can also withdraw 100 euros. That's good. But now what the model will do is basically it has a list of what has happened before. So at some point you like deposited a lot of money, and then you used your credit card to pay for something, and then you withdrew 200 euros, and now you go again and withdraw another 100 euros. So basically this will basically just be appended here, right? So you have this log, and if you want to see how much money you've got, just replay it. Okay, I had this much money, but I used up this amount, this amount, this amount. All right, my balance right now is 2,000 euros. Okay, this is event sourcing. Fair enough?
How do you keep a log of all the events that happened in the last 10 years?
Can you, let's do like this. Can you ask this question in like 2 minutes? I will give you a sign, okay? And then I have an exact right slide for you. Okay, so I will come back to you. But first, so event sourcing, what does event sourcing bring to the table? For one, now that we have the whole history, it's really nice. We can replay this history and restore our state. So if something happens, our actor drops out of the sky and crashes. We can just spool it up again and we can restore the state because we have all the history, right? So we just replay one event by the next, and at the end we will get the current state we had before the crash. Another very, very cool thing is, you know, your boss came to you and said, I want this feature and I want it, basically, it should be working already for the last year. With event sourcing, you kind of can do it. You can go ahead and use your old data for your new features. Basically, you write your new code and replay all the history that happened. And if your code uses stuff that's in the history, of course, you can basically calculate new state out of it. That's pretty neat. Another thing that's pretty useful, I mean, who didn't have the situation? In production, you get a call during the night, something went wrong, and then you have to debug it, and you have no idea what happened, and you have no way to restore it. with event sourcing, you can basically pull some part of this event store, of this log that was kept. And yeah, basically you can just, well, if the people who are in charge allow you to, because the data might be sensitive, but maybe you can pull it into your development environment and replay the data and see basically what crashes when you do that. That's kind of neat. Another cool thing is basically if you store it in this way, you will never have to delete data, okay? Because everything that happens is a new event can be added. So basically, you have two operations you need: append and replay everything. You don't need any random access. You don't need, I don't know, you don't need to delete stuff. You don't need to resort it. You don't need an index. So for this, you can really use optimized storage technologies, okay? To really get the best performance out of this. All right, and now, your question again, please?
Obviously, if you pile up too much historical data, it will be not practical to do that.
This is exactly right, and this is why in event sourcing there's something like snapshots. Snapshots are basically what will save you in this event. What you can do is basically a neat trick that, okay, it's a bit of cheating, right? So I said you don't store any state, but with snapshots you do exactly that. You go, at some point you say, okay, at this point I don't care about the past, I want to store the state I have at this moment. And you will again have all the, basically all the history that starts accumulating from this point on. All right? So basically you can, if you really at some point should have so many events that it slows you down, then you can say, okay, breakpoint here, I save a state, and again, let's start from this point. Thing is, you won't need to do this very often. I mean, you should and you shouldn't do it really often. This is like you know, premature optimization is the root of all evil, right? So basically, first make sure that you have a problem, and then you can use snapshots to optimize it. But yeah, it always depends on your domain, and you shouldn't use it like everywhere. Okay? Normally, you will have some, I don't know, most objects will be, or most, yeah, basically in most actors, for example, if we're in Akka, we'll have only some messages or some events in the log. And you will have, I don't know, 1 or 2 really active actors. And for them, maybe use snapshotting, but not for all. So that's basically what snapshotting is about.
Snapshots really need you stop the application?
No.
Snapshot,
no.
Or you are rewriting the event history?
No, basically you just say at one point, okay, this is my state, please store this state. And if at some point I want to start replaying from this point on.
If you have real data, it is quite complicated to get a consistent snapshot if you don't stop everything. What I could think of,
not really. I mean, you have to think that you don't write concurrently from all sides. Okay.
Yeah.
I mean, especially in Akka, you will only have writes at one point, and you can very easily stop it at this point.
Typically, the snapshot will be an asynchronous process. So you have your event store, your event history, and then as an asynchronous process, you can produce your snapshot. So reading back, your actor would then start with the snapshot, and the remaining parts of the history you haven't seen yet.
so you are rewriting the history.
Only rewriting the history, you're just creating an additional snapshot. You keep your history, and you just have a pointer in time where you say, this is the aggregated history up until here.
Okay.
No, you post-process the history.
You post with the refreshing, it's reprocess. Okay, but yet you post-process. Okay, yes, I got it. Thanks.
All right, cool. I don't need to do anything. That's cool.
Also, if you use persistent data structure, then taking a snapshot of your data is trivial because I mean you do not mutably update your data. You sometimes mutably update the pointer to your data, but then you can just take a pointer to your old data, remove all the events, and then you have still a copy in your memory which you can do whatever you want with.
In principle, you're right, but it might be quite hard to get the point of time you're recovering and the events that match to them. You have to match them together. But of course, yes, it's doable.
Maybe we can have this discussion afterwards.
Yeah.
I still have a bit of a deadline, right? So still lots of stuff I want to show you. But good point actually, yeah, it's an interesting discussion. All right, away from the cute kitties, and okay, one more slide before we get to the Akka part. So basically, if you combine everything, how it would look like is basically in your command model, you would transform these commands into events, and then basically just publish these events, and the read model can subscribe. Okay, and here you have like this read optimized state database which stores the state and which will be used by the query models. This is plural S, not by accident. So here you really have many for one command model. I mean, basically you will have also many of these boxes, or you will also have many commands. But the point is you will have many query models for one command model also. Right? So that's basically the simple idea to combine them. It's basically very natural because these commands are messages, right? So you can just persist them then and basically create a state out of them again. All right, Akka. Heard of it? Oh yeah.
You have no back channel for the commands, so basically the information,
yes.
There's no information going back.
Yes, exactly.
But if you have some kind of confirmation that the command actually succeeded, would you have to poll the view model for that? Yeah,
that's what I meant before, that ideally you would update your UI to basically not need some kind of confirmation, right? So that guide your user to a point where he really doesn't expect any confirmation. Or if you want to, you can send, for example, a confirmation by email or something like that, right? Set up a query model that will basically be notified whenever something happens, which will not answer any queries but send out emails, for example.
But in case of validation errors, you want to get error messages and you want to get...
Yes, that's right. So for that you need a back channel. Yeah, that's right. That's right. Yeah. I mean, for that you need some way to notify the user. But basically, what you don't really want to do is basically have a dependency on, okay, I need to know when this was written. You can say to the user, okay, your request was validated, it's okay, I put it into the queue to store it, basically. But you don't say, okay, this is how the model looks after your request, okay? So basically, if you change something, you don't want to go to the query model and look up what his changes meant to the whole system. You just want to say, okay, you did something, it's okay. I accepted it. It will find its way into the current state. More or less clear?
You probably don't want to or need to update all the groups consistently, immediately, synchronously.
Yeah.
But maybe some of them, or at least something in the user session.
You should avoid that if possible. I mean, it will slow it down. It will tie those two models together, basically.
I agree, but I don't see that you have to do that aggressively.
Yeah, I mean, it's always a question about theory and practice, right? I mean, like I said, you will have some downsides if you do it. It will be tightly coupled. You will have some performance issues, maybe. You can also say just, okay, this one, I accept that, and I have other query models which are fast and completely decoupled and everything works fine. Yeah, sure. I mean, like it's like always. You don't want to be too dogmatic. You need to find the approach that works for you. All right, Akka. I think I can skip over most parts because A, a lot of you know of Akka already, and B, Heiko did an excellent job of introducing Akka already. So just shortly, Akka is a toolkit for performant and distributed applications. It builds on actors, location transparency, and fault tolerance, basically to make this creating reactive applications easy. Actors are basically just objects communicating via using messages. Nothing else can happen. The only way an actor can change state is by receiving a message, okay? And the only way it can communicate with another actor is by talking to him, to sending messages, right? So basically, actors are, I don't know, like sending SMS. You can't really go to another person and change stuff in his brain. You can send him an SMS, and he will do maybe something you want, maybe not. Messages are immutable, so you can't go ahead and, I don't know, change the SMS you sent to the other person. It's just, you sent it already, it's out. It was bad. Tough shit. Each actor will only process one message at a time. So basically, okay, some people have two 2 mobiles, but they also will only read 1 SMS, okay, when they read the next one. It's the same with actors. This is kind of neat, because now you're working, basically, you have several actors, they all work on one machine, on one JVM, they use all your processes, but each one of these actors only basically processes one message. So you have got this single-threaded illusion. You don't need to worry about stuff like threads and synchronize and all the hell that Java multi-threading brings. It's very simple to just code down, right? You have this one message you're working on, you just code. Another nice thing is with supervision. So we've got these parent actors, which basically supervise the children. It's the way it should be, right? And every time a child misbehaves, the parent needs to punish it. I think that's clear. All right. Like I said, Heiko covered everything, so I hope I'm fine with this very short introduction. All right, let's get to Akka persistence, which will be basically the main part of the rest of my talk. Akka persistence is basically, well, you saw it already in action before. It's a method to allow you to persist the state of an actor, right? So actors, like I said, they send messages. These messages will change their state. And at some point, you might be really interested in keeping that state, even if your actor crashes. And, well, this is, or your program crashes. And this is one way to do it. And the neat thing about this, and why I mention it here, is Akka persistence is based on event sourcing. So basically, like Heiko showed you already, this, you will get some commands in, you will transform them into events, and basically then in this journal you have, you will just keep the history of the events that you saw. Like event sourcing does, events will be replayed on failure. So if your actor crashes and burns, at some point he will be reborn, and all the events he saw before will be replayed, and it will have the same state. This is why we saw the messages in this reactive flow demo at the end. That's really nice. I've got so many references from you. It's really cool. And yeah, of course, it supports snapshots. So if you've got a really long chat, you can just snapshot at some point and then basically store all the messages and basically replay just the snapshot and all the photos. You probably won't need it, but yeah, you can do it. I mean, for this reactive flow stuff. All right, and what Heiko did not show you, he left something for me, is you have another part. You have this persistent actors, which can store the state, but you also have views, and views are really neat because views allow you to subscribe to another actor. So when you have an actor, which basically just persists all events it received, you can have this view, and this view will basically receive all the events from the actor, right? So it can just subscribe to everything at once. Let's take a short look at this persistent actors. Basically, this is the central concept. So if you use Akka persistence, you use the persistent actor. It was a bit different before, but since version 2.3.4, where the big rewrite occurred, this is basically the centerpiece. Before you had some other stuff, you can also do command sourcing, so leave out events and just store everything that comes in. Now we've got only this. Basically, you receive commands and persist events. That sounds like commands, CQRS and event sourcing combined. That's great. It supports recovery and snapshots. And yeah, it's cool for event sourcing and like command side QRS, obviously. Okay, this is how it looks like. You will have an actor that's a persistent actor. It will have an ID. The ID is important because you have all kinds of actors and you want to basically just make sure at some point, okay, these are events of this actor and these are the events of this actor. Also, we need to subscribe to the actor, right? Like Heiko said, if you know normal actors or the usual normal Akka actors, they only have one receive function. This one has two. It has one which is called receive command, which does exactly that. It receives commands and basically out of these commands creates events and persists those. Okay, so we'll have this persist statement somewhere. You will have this, basically, you create an event out of a command in some kind of way, and basically you then have this update state, which is interesting because, or useful, I mean, it's not required, it's best practice, because you want to do the same stuff if you first see the event or if you recover. Oops. if you recover basically during recovery when you see that event again. You want to get the same state afterwards. Yeah, that's about it. High level, we will see some code examples later on to basically show you what you can do with this stuff. The other half of Akka persistence, or for our use case at least, is persistent view. Like I said, it allows you to subscribe to events. All the events will be replayed, so everything the persistent actor persists will be basically shows up in this view. And you can basically have as many views as you want to subscribe to the same actor. It doesn't work the other way around yet. This is, yeah, it's coming at some point. There's very active discussion. I think this will incorporate Akka streams, so basically they are waiting to finalize Akka streams before they get started at this point. Yeah, this is exactly the reason. So you can only subscribe to one actor, and that's not, of course, not very flexible. At some point, you might want to aggregate that stuff, or just to, I don't know, to get some events, not all of them. Yeah, there's a very active discussion with some people like Greg Young, the inventor of CQRS, and Von Vernon, who wrote a very, very influential book on domain-driven design. They're all discussing how to make the query side of Akka persistence better. And yeah, if you've got so high-profile people in the discussion, I think something good will come of it. But still, I think it's some months away yet. But you can do a lot with what we have right now. Our persistence view looks like this. Yeah, surprise, you extend persistent view. Now you have two IDs. One is called the view ID, which is basically, well, the ID of a view. Basically, Akka can keep track of what this view already saw. And yeah, obviously the ID you subscribe to. So this will be basically, oh, it's issues. Spoiler alert, but again, doesn't matter. Yeah, and when it's just a normal actor, it will have a receive method, and basically you will receive all the events the actor persisted. Simple as that. All right. So yeah, I prepared some demo code to just show you how to make it work, how to design such a system. This change actually I made while you were talking, so basically it was called something different, but as you said, it needs to be something with reactive. So now it's reactive issues. What is it? Let's suppose we wrote a, yep. No, only the first time. Or basically when it's crashed itself, when it will also.
How do you recover these now? How can you recover?
It will be also, the events will be replayed to the view. Yeah, so it will, no, it will not receive the events if the persistent actor recovers.
Yes.
But it will also receive them again if it self-recovers.
Okay, I don't know how this is accomplished, but
okay. It's
so it requests those messages again from the.
No, it basically just yeah, just Akka realizes at some point, okay, it started again, and it registers, and basically when Akka knows, okay, I need to replay everything again. Yeah. Okay.
It's the journal.
Yeah.
So it gets those events from the journal.
Yeah. True. Yeah.
And it can also make use of snapshots to speed up the recovery.
I think so. I don't know.
Should. Yeah.
Snapshots should be specific to the needs.
Actually, I'm not sure. I'm not sure about that. I think it should be, but I'm not really sure. I need to check it out. I mean, yeah, good point. Yeah. Like I said, the view part is still a bit of a work in progress, so things might change. Okay. Back to this stuff. So basically, I prepared a joke, so I need to get it through. So basically, you build a system without Akka and CQRS and event sourcing, and now you really need an issue tracker to be very performant to just deal with problems, right? So this is what this reactive issues is. Prepared too much. Okay. Nevertheless, what we need is we need some features for our issue tracker, right? So the product is nothing without good features. What features do we need? We need to create new issues, a lot of them. We need to add comments to the issues, like, okay, this is really bad issue, fix it please. It doesn't work on my machine, fix it please. All right, close issues, of course, if something gets done. And then you, of course, need to show all issues that we created and show all comments for one issue. I mean, there's a lot more stuff, but this is actually the code I want to show you right now, all right? So first, we'll have two models. The command model will basically be very simple. We don't need any IDs. We will just identify our issues by name. And this is actually only one issue per name will be allowed. Okay, so this is our primary key basically. After an issue is closed, we don't want to allow any more actions. That's it on the command side. The query side, pretty simple, no logic, just return whatever the user wants. Okay, code, yay! Lots of it actually. So, I mean, let's just dive in. This is our, basically, this is what we need as for code to create a new issue, okay? So we have a persistent actor, and basically this actor will receive a command, create new issue, all right? This is the interesting part about, it's also best practice in event sourcing. Commands have active names in the present, right? Do something, create a new issue. Events, on the other hand side, will represent the past. So they will be passive and basically in the past tense, okay? So issue created is the event that belongs to that one. As I said, we only want one issue per name. So basically, here we just check, okay, this new issue that's being created, is it already existing? Okay, so this is the validation in our command model. If everything checks out, we persist this event we created out of our command. Basically, we just need the name information. Okay, so we throw basically the command away and just take the name and create our new event. And with this, we just go down here, update state. Cool. The event we had is issue created. And what we do here is we create a new actor to be basically the persistent actor for this issue, okay? We create one actor per issue, all right? Basically, this allows us to have all the history for one issue to be in one place, in this one actor. We could, of course, say, okay, we store everything in here, but that would be very cluttered, okay? So we want to really decompose our problem into smaller parts. This, of course, is not very resilient. It's not very scalable. Basically, ideally, you want to use cluster sharding here, what Heiko basically also used in his example. I just didn't want to introduce more concepts for this short talk, shortish talk. All right, so basically, we create a new actor for each new issue, and basically, we store the name so we can find it again, okay? What happens up here then is if any command comes in for this issue, so we have basically our own sealed trait for commands in issue. So all the issues that command can handle will extend this trait. We can basically send it on. We also have a guard here to just make sure that the issue really exists. And when we just forward it, this issue's actor has nothing to do with it anymore. Just forward it on and the issue can do with it what it wants. Right here, you see, I do not return anything to the user. I just log it out. This may or may not be valid in your case. It really depends on your use case. If you have a UI, you probably want to return something to the user. If you have some backend system, basically, maybe not. But yeah, it's like I said, it's just a design decision or basically a business decision also. Okay, cool. One feature down. Let's get to the new one, the next one. We want to add a command. Okay, so we have an issue, and we want to basically say, okay, this issue is super important. What happens? We have a new command, which is called add command. Then we create an event out of this. So basically, this gets passivated, command added. We take some stuff from this command, add in some other stuff. You can do that. So basically, you can modify what data you received in your command. Okay. Wouldn't make sense. For example, we really want the time to be the current date, okay? So basically, we take this event, and this part will be persisted. So this date stays, okay? So if the event will be replayed at some later time, it will still be this time, not any other time. It will all, for eternity, be this time. The events are immutable. All right, that's about it. We don't need to basically do anything in the update status. It doesn't change anything, okay? This doesn't return the commands. So what are we interested in really storing here? Nothing. the fact that, that the command was added is not important for the command model. We can just forget it. We don't need to update any status. We can log it, for example, or do something else, but that's about it. It doesn't really matter in this scenario. A different case is the close issue, okay? This also operates on this issue actor, but in here it's important to know, is the issue closed or is it not? So basically, our state will be basically a flag. Is this issue still active or is it closed? So in our, do I have more? Really? Okay. So basically down here in update status, if the issue was closed, we turn just the flag to true, and that's it. Okay. If the events get replayed and it comes across this issue closed event, it will just set the flag and be done with it. All other events can be safely ignored. For receiving commands, we again have to validate. Okay, so we get a command in, we have to validate this was a valid command in our scenario. If the issue is already closed, it's not. We will just log an error in this case. You might want to return an error message to the user. Okay, interesting part here. What happens when a close issue command comes in? I mean, closing issue is basically a mix of several parts. Okay, at first you will have some kind of command also, right? So the person who closes the event will want to say something to the people who opened it. So like, okay, it's fixed, or it will never be fixed, or it works on my machine. So basically, you will have also some kind of message. But we already had some kind of event for that, okay? So let's just reuse that. We add a comment edit event, persisted, and then afterwards just create a issue closed. This can just be a case object, right? No parameters whatsoever. Just close it and be done with it. No information needed anymore. What's interesting about this? Persist will make sure that this is completed first, then it will continue going on to issue closed. There is a variant of persist async, which will continue with processing basically other stuff. But it will still guarantee that the messages are processed in the same order. Okay, you can use that, and I mean, actually, for the command model, it would probably be a good idea because you can just optimize it. You don't store really, you don't do any state updates outside of here, so you're really safe to use that. Okay, this is the command model. All the features implemented. Yay. We've got two features left. Query model. We want to show all the issues. Basically, we have a persistent view. We use this issues actor as basically our source of events. And we will receive this events. So basically, we had an issue created event in the actor. We will receive this issue created event in the view whenever it occurs. Again, here, we will create views for each of the single issues we have. Basically, the same model. Again, here, you could use cluster sharding. And then you will, of course, get the queries. Okay, so this is the events. And now we will also have queries to basically return something. Like this, get all will just create a set containing of all the issues you have. That looks funky. And again, you will have queries which are not meant for this, basically the set of all issues, but you want to get, for example, the commands for one single issue. Again, you do the same thing you did before and just forward it down to the special view. All right, last code slide. No, I think basically I took longer than I needed, but yeah, okay. Basically, this is the second view we have. Also, this one uses the issue actor as a source. And basically, now our state is the set of commands, right? So every time a new command comes in, we add it to our state and keep the state up to date this way. If someone wants to see what commands we received, we just send them back to him. Very easy. All right. Any questions to the implementation? I mean, lots of stuff, lots of code at a late hour, I know, but I will put it on GitHub so you can just sort it out and play around with it. I mean, this is basically a real project, so you can just import it in IntelliJ and run it. I will put it on GitHub and post the link on the Meetup site, so we can play around with it and explore it a bit. All right, so CQRS and Akka. Basically, as a first conclusion, event sourcing is really a great fit with Akka because Akka is already message-driven. You have events, or you have messages which are being exchanged, and going from these messages to events, persisting those to keep the state is really a great fit. So Akka persistence is really a neat way to make sure that you don't lose your active state. CQRS can be really useful. I mean, for this application, I don't know, maybe not. It really depends on your use case. I wouldn't force CQRS basically on everything you have. That's not the right way to use it. But in some cases where you really need the performance of a read side, don't want to basically have everything in one place, to want to separate it a bit, perhaps have it on different cluster nodes. I mean, with Akka cluster, you can also just set up roles for each node and have several nodes for reading and only one node for writing, for example. So you can really do neat things with it. But be careful. I mean, CQRS is useful, but don't overuse it. Like I said, clustering is also a cool thing. Heiko showed you a bit what clustering can do in Akka. It can do a lot more. It's really a good thing to look into. And basically, while I was working on this presentation, an activated template showed up, which basically also introduces CQRS and Akka. So there's also a working example. If you have activator, just pull the template. It's actually it's pretty similar in the concepts. They use the sharded, cluster sharding regions. So that's also a good way to check it out, how that might work. Okay, conclusion on CQRS and event sourcing. This is no silver bullet. So basically, like I said, don't overuse it. Where I heard a lot of good things about it is with microservices. So basically, because you can really separate write and read models into different services, which can be really neat, because you can really use some different technologies which are really fitting to this one concept, like reading or writing. So this can be a lot of fun. Okay, you all obviously need some kind of technology to synchronize them both, right? So like some kind of publisher-subscriber stuff. I mean, there are some event store implementations which basically allow you to store events and publish the events to subscribers. This can be used very nicely with this. But of course, CQRS, like I said, it's no silver bullet. Make sure it fits your domain. Make sure to really understand your domain also. Okay, so this is very important. Don't use it up front in a new project. You don't really understand what's the whole ideas behind it. That's like, yeah. I mean, this is basically, you have to know your domain, but that's true for basically all problems, right? All technologies you want to use. If you don't know what you're working on, then yeah, you will do some stuff that's wrong, probably.
So how flexible are you in this case? I mean, requirements change.
Yeah, requirements change. That's right. But I mean, that's why I don't know. Like I said, you really need to be sure that it fits the domain. If it fits the domain, then the requirements probably won't change so much that this isn't working anymore. Okay? But if you're in a domain where it just works, maybe then requirements will come in that will make it hard to use. But of course, at some point your boss may come up to you, okay, we need this feature and it breaks everything. But that can happen. That's true for everything basically, right? I mean,
so from your point of view, is it harder to become sufficiently flexible?
I think working with CQRS is you need to think differently. So it's not trivial. You need to think about a lot of stuff, and you need to make sure you understand your domain, you understand the topic or the technology or the stuff. So yeah, I mean, I really like it. It's a cool idea, and you can really use it well. But I wouldn't just run head into it. I would really make sure to maybe make a proof of concept before, or to really, yeah, proof of concept is probably a good idea in this case. All right, and just keep in mind this is just one tool in the toolbox you have, so don't overuse it. Use different stuff for places where it fits. Ah, sorry.
As you said, CQRS solves some problems,
Yeah.
but actually brings some complexities also.
Yeah, of course.
There is no free lunch.
No, there's no free lunch. Absolutely.
And for example, if I'm starting a new startup today,
Yeah.
I have another force, time to market, that will probably make me choose to use, I don't know, Hibernate instead.
Yeah.
But in some place, sometime down to the road, I will probably have this problem with scalability.
Yeah,
But
yeah.
a good problem.
Yeah.
But there is some kind of metric, breaking even, where, for example, okay, with this amount of transactions per second, now I need to think about to start to use CQRS. Is any kind of
No, I mean, it really depends on the use case. I mean, for one case, it might be like 10,000 users. For another, it might be 1 million. It really depends on what you have, what you need, right? It's really case-to-case basis. But yeah, basically, when you have a problem, you will know it, right? And that's probably you should have monitoring in place to really know before you get the problem. But that's just basically making sure you understand your own system. You understand when your system is not working anymore and will not survive. And that's the point you basically should really think about using something different, maybe using something like CQRS. All right?
Yeah.
Okay, so with that, thank you very much for your time. I finished almost in time. Yeah, thanks. We have still some beer, maybe some cold pizza, I don't know. Like Christoph said, we will be open here, so have fun. And if you have any questions, you know where to find me. Thank you.